Now we have taken so many applications and begin. We have considered so many applications of trigonometry. We have considered the right angle triangle when we are seeing the SOHCAHTOA tour. We have also considered the sine rule as well as the cosine rule. Okay. After looking at the sine rule and cosine rule, we looked at bearing. Where in bearing we understand north, south, east, and west, where the angle is starting from 0 degrees and moves in a clockwise direction. Now I want to look at another application of trigonometry, and this will find in the angle of a single line. So let's look at it together. We know that the angle on a straight line is equals to 180 degrees. What if we have an equation of a straight line, of a line? We know that the equation of a line is equals to is a line represented by the equation of y is equals to mx plus c. So if you have this line, we can have y is equals to mx plus c, where m is the gradient and c is the y-intercept. So we can call this point C. So the question now is what is the angle theta that the line forms with respect to the x-axis? What is the angle theta, or what is the angle theta here? Now, how do we get that? The expression that we are going to use is simple. That tan theta is equals to the gradient. And when we use this expression, we are reminded of the inverse trigonometric functions that we arrived. That if we have sine x is equals to a, then x is equals to arc sine of a. If you have cos y is equals to b, arc sine, and if we have cos y is equals to b, y will be arc cos of b, and if we have tan z to be equals to c, then z will be equals to arc tan of c. Now applying the last concept into this, we can say that m, that means angle theta, the equation, the angle of the straight line, or of the angle of a straight line, is equals to arc tan of m. Now let's take some examples to understand this part completely. Let's say we are given the equation of a line y is equals to 2x plus 5. We are asked to find the angle that the line makes with the x-axis, just as we have in this representation here. Now with that, we just compare this equation of a line to the formality. Then we have m to be equals to 2 and c to be equals to 5. M is equals to 2 and c is equals to 5. So let's apply tan theta is equals to m. Therefore, tan theta is equals to m is equals to what? 2. So with that, we can easily evaluate the angle the line makes with the x-axis. Therefore, we are saying theta will be arc tan of 2. So you can use our calculator and say arc tan of 2, and this would give us 63.43 degrees. Similarly, we can have another equation of a line. Let's say y is equals to 1 over 2x plus 3. And if we compare this to y is equals to mx plus c, we can see that m is equals to 1 over 2. If m is equals to 1 over 2, that's 0.5. With that, we can evaluate the angle using tan theta is equals to m. So therefore, the angle the line y is equals to 1 over 2x makes with the x-axis is to give us arc tan. This m here is 0.5, so it will be arc tan 0.5. and arctan 0.5 is equals to 26.56, or let's say 57 degrees. So we can see how easy it is. Now let's look at another concept. Let's say question number 3. What if the question has a negative slope? That means we are saying y is equals to minus mx plus c. So we can see now two things. That in these two questions, we have that y is equals to mx plus c, because m here is positive, and when we have a positive slope, the line is moving in this direction. Y is equals to mx plus c. Now what if we have y is equals to minus mx plus c? That means we are saying the line is moving in this direction. So we are saying the angle it makes is this. It will still hold with the same formula that tan theta is equals to minus m. So let's do this together now. Y is equals to minus 0.5x plus 3. So if you compare this to mx plus c, we would see that m is equals to what? Minus 0.5. So if m is equals to minus 0.5, then if we compare this using this equation again, that tan theta is equals to minus 0.5, then theta will be arctan minus 0.5. Now we can use our calculator to derive theta to be arctan minus 0.5, and we will have a negative angle of minus 26.57 degrees. Now since angles are measured counterclockwise, that means anti-clockwise, that means since angles are measured in this direction, then the positive angle will simply be 180 minus 26.57 degrees, and this will be equals to 153.43 degrees. So the angle this equation makes with the x-axis is 153.43 degrees. Now there are special cases. We understand that the equation of the line is y is equals to mx plus c. But then when x is equals to 0, we have y is equals to c. Okay? And this shows that we have a parallel, this shows that we have an horizontal line. That means we are saying y is equals to c. So when y is equals to c, if you compare it to y is equals to mx plus c, we will see that m in this case is equals to what? 0. So let's look back to the formula that tan theta is equals to m. Therefore, we are saying that tan theta is equals to 0. So theta will be what? Arctan 0. And arctan 0 is equals to 0 degrees. This can be 0 degrees, and it can also be what? 180 degrees, because they fall on the same line. So this is when we have a horizontal line. What if we have vertical line? And in a vertical line, our y is equals to 0. So we have y is equals to mx plus c. But in a vertical line, y is equals to 0. So we'll have 0 is equals to mx plus c. So we can simply say that we have x to be equals to, let's say, minus c over m. And we can just simply say x is equals to k. So in a vertical line of x is equals to k, we will have an expression, a graph like this. X is equals to k. Now, in this case, we will have that the angle is equals to 90 degrees because it is perpendicular to this. But then how do we arrive at this form of angle? So let's compare now. y is equals to mx plus c, and we are comparing it to x is equals to k. Now we can see now that the coefficient of x, we use tan theta is equals to m, the coefficient of m in this case is equals to 0, or is undefined. M in this case is undefined or infinity. Therefore, we are saying that tan theta is equals to infinity, and theta will be arctan infinity, and this will end in special angles. That's when we have tan 90 degrees, it is given as undefined. So we have theta to be what? 90 degrees. So now let's quickly have like a summary of what we have learned so far. The first thing is when y is equals to mx plus c, the slope m is equals to m, and the angle can be represented as tan theta is equals to m. So we can easily evaluate theta from here. Likewise, if we have a horizontal line of y is equals to c, slope m is equals to 0. And if we use tan theta is equals to m, we have that theta is equals to 0 degrees. However, if we have a vertical line of x is equals to k, we have that the slope m is undefined, infinity. Then we will use tan theta is equals to m, then theta is equals to 90 degrees. Infinity here means undefined. So let's have one more question just to explain the term here. So let's assume now we have the question that's find the angle of the line of x is equals to minus 3. X is equals to minus 3 here is corresponding to x is equals to k. Therefore, the angle theta is equals to what? 90 degrees. Similarly, if you're asked to find the angle of the line of y is equals to 4, y is equals to 4 is corresponding to the horizontal line, and the angle theta is equals to 0 degrees, because if you compare y is equals to mx plus c with y is equals to 4, then we can see that our m is equals to 0. If we use the formula that tan theta is equals to m, which means that our m is equals to 0, then our tan theta is equals to 0, then theta will be arctan of 0, which is 0 degrees. Now we have considered angle on or angle of a line. So we have seen 3 expressions, 1, 2, and 3. Now we are still on the application of trigonometry, but this time around let's move on to how to find the angles when we have 2 lines.